Okay, so we can get started. Notice in this first one, right, all of these just say find the solutions. We're doing A, B, and C, so it's polynomial equations, radical equations, and rational equations. I'll start with the polynomial equations, bless you. So I'm going to jump around. I'm going to do 1, and then from 1, I'll go to 7, 8, 9, 10. Right, questions like those. All right, because that was the one that we did some weeks ago. So I want to make sure you all remember it. All right. Okay, so looking at this first one, this is a polynomial equation. First thing we want is for it to be set equal to 0, which it is. After it's set equal to 0, what do you want to do? Okay, yeah, so if you have 4 terms, you want to group, right? Factor by grouping. Pull out a GCF from the first group, right? From here is going to be an x squared, and from here is going to be a 1, right? So we get an x squared plus 1, and then you're left with an x minus 6 equals 0. And now that we grouped it, we want to set each factor equal to 0. So it's going to be x squared plus 1 equals 0, x minus 6 equals 0. Yeah, if you see 4 terms, you want to group it. All right, and then we can solve this one. We want to add 6 on both sides. One of our answers is going to be 6. And then our other answer, we can subtract 1 from both sides, and you get x squared equals negative 1, right? And then you want to take a square root, and then you get x equals plus or minus. Do we know what the square root of negative 1 is?
1.
I. Yes. Right, square root of negative 1 is I. Right, don't forget about the i's. All right, so those are our other 2 solutions. Right, and you can kind of tell how many solutions you're going to get based on the highest exponent. If it's 3, you should get 3 solutions, and we get 3 solutions here. Okay, so like I said, I'm going to jump around. Let's go to number 7. All right, and again, you're not going to have room. You can write it off to the side. I'll write it to the side here. We have 25x squared equals 100, x to the 4th. All right, this is another polynomial equation. So the first thing we want to do is make sure it's set equal to what? 0, right? Let's set it equal to 0. I'm going to subtract 25x squared from both sides, and then you get 0 equals 100x to the 4th minus 25x squared. Now that it's equal to 0, we can factor. What can we factor here? You can take out 25x squared. Right, the greatest common factor, 25x squared, and you're going to be left with, hold on, 4x squared minus 1. All right, and this equals 0. Now that we factored it, we can set each factor equal to 0. So we get 25x squared equals 0, and 4x squared minus 1 equals 0. All right, divide by 25 on both sides. So we get x squared equals 0. And then square root both sides, we get x's. Square root of 0 is 0. You could say plus or minus 0, but those are both just going to be 0. So we get x equals 0 twice, right? That accounts for 2 of your answers. And then the other one, we want to add 1 on both sides. And then we get 4x squared equals 1. Divide both sides by 4. We get x squared equals 1/4. And then again, square root both sides. So we get x equals plus or minus 1/2. Right, remember if you're dividing under a radical, you can square root the top and square root the bottom. All right, so far so good? Any questions? Okay, after 7, let's try 8. Again, I know there's not a lot of room. You can write it to the side. So we get 9x to the 4th minus 37x squared plus 4 equals 0. Right, this is a different kind of problem. First thing you always want to check is if there's a GCF. Here, there's not one, right? There's no GCF here. Right, it doesn't look like we can group, we can do anything like that. So what we're going to do is we're going to factor it the same way we would a quadratic. This is a quadratic-like polynomial, right? Meaning you can factor it the same way that you would a quadratic. Right, and you can tell that you have one of these when the exponent on the middle term is half of the exponent, or half of the biggest exponent. Right, so you can factor it the exact same way you would a quadratic. So we can do 9 times 4 is going to get you 36. So we want numbers that multiply to 36 and add to negative 37. All right, can we think of anything? Good, negative 36 and negative 1. And so from here we can split up our middle term. It's going to be minus 36x squared minus 1x squared. Remember, our middle term was a squared term. And then we can bring down the 9x to the 4th and bring down the plus 4. All right, and then now we can group the first two and group the second two. Pull out a GCF. In our first group, what can we pull out? All right, we can pull out a 9x squared. All right, the GCF. And we're going to be left with an x squared minus 4. In our second group, we can pull out a negative 1 just to get the insides to match. And then we get 9x squared minus 1 times x squared minus 4 equals 0. And now we set each factor equal to 0. All right, so here we can add 1 on both sides. And we get 9x squared equals 1. And then divide both sides by 9. So we get x squared equals 1/9. And then we want to square root both sides. So we get x equals plus or minus 1/3. Right, again, if you're dividing under a radical, you can square root the top and square root the bottom. And then for our other equation, we can add 4 on both sides. And we get x squared equals 4. And then we can square root both sides, and we get x equals plus or minus 2. So we get 2 solutions there and 2 solutions there. All right, how was that one? Okay, so let's try number 9. For this one, okay, number 9, let's subtract 27 on both sides. We always want to set it equal to 0. So we should get x to the fourth minus 6x squared minus 27 equals 0. This is another quadratic-like polynomial. So you're able to factor it like a quadratic. Right, so all you're doing here is you're looking for factors of negative 27 that add to negative 6. All right, do we know what that's going to be? Okay, it's going to be negative 9 and 3. We get x squared minus 9, x squared plus 3 equals 0. And now let's set each factor equal to 0. X squared minus 9 equals 0. X squared plus 3 equals 0. And then we can add 9 on both sides. We get x squared equals 9. Square root both sides, we get x equals plus or minus 3. Okay. And then for the other one, we can subtract 3 on both sides. We get x squared equals negative 3. Square root both sides, we should get x equals plus or minus, what should we take out of that radical? An I, right? There's a negative under the radical. We get I squared root of 3. So we get 2 answers here and 2 answers here. All right, let me erase that. All right, 4 solutions total. Okay, any questions on those? All right, so solve the polynomial equations the same way you would quadratics, right? Get everything equal to 0, and then see if you can factor it. All right, let's try some radical equations now. All right, so let's try number 2. All right, so I'll write it over here so that there's room. The first thing we always want to do is make sure what is by itself.
The radical?
We want the radical by itself. Is it by itself here? Yeah, so we can do what to both sides? Square. Right, we want to square. The opposite of square rooting something is squaring. Right, so then the square root and the square cancel out. And we get x minus 2 times x minus 2 equals 2x minus 4. And now you want to FOIL this. Set it equal to 0. All right, so this is going to get us an x squared minus 4x plus 4 equals 2x minus 4. And now this is a quadratic. We can get it equal to 0. So let's subtract 2x and add 4. And then we get x squared minus 6x plus 8 equals 0. And now we want factors of 8 that add to negative 6. There's going to be a negative 4 and a negative 2. So we get 2 answers here. It's going to be x equals 4 and x equals 2. Now these are the equations that you need to check your solutions. With square roots, you don't want them to equal negatives, right? If it equals a negative, you get an untrue statement, then it's no solution. Right, so let's check x equals 4. Right, so we're going to check. And we're going to do x equals 4. Gross. Plug in 4. We get 4 minus 2 equals the square root of 2 times 4 minus 4. 4 minus 2 is 2. 2 times 4 is 8. We get the square root of 8 minus 4 is going to be the square root of 4. Right? Is 2 equal to the square root of 4? It is. Right? We get 2 equals 2. That's true. So x equals 4 is a solution. We also want to check x equals 2. So we get 2 minus 2 equals the square root of 2 times 2 minus 4. So we get 0 equals 4 minus 4 under a radical. We get 0 equals 0. That's true. Right, so x equals 2 is also a solution. Okay, yeah, let's try number 4. It's going to be the square root of x plus 2 equals 4 minus x. And let's check first if the radical is by itself. Right now it is, right? It's by itself, so we can immediately square both sides. Square the left, square the right. Over here, the square root and the square are going to cancel. And we get x plus 2 equals 4 minus x times 4 minus x. And then we want to FOIL this. We get x plus 2 equals 16 minus 8x plus x squared. I skipped some steps to do that. If you want to write it out to verify, you can. And now this is a quadratic equation. So we can get everything to one side and set it equal to 0. So let's subtract x on both sides. Subtract 2 from both sides. We get 0 is 14 minus 9x plus x squared. And now we want to factor this. If it's easier for you, you can write it in standard form. So you can write x squared minus 9x plus 14 equals 0. And now you want factors of 14 that add to negative 9. What are they going to be? Good, we get x minus 7 and x minus 2 equals 0. All right, and so we should get x equals 7 and x equals 2 as our answers. But now we want to check. All right, let's check our answers by plugging them into the original equation. Let's first check x equals 7. All right, so we get 7 plus 2 under a radical equals 4 minus 7. And we get the square root of 9 is negative 3. Is this true? Square root of 9 is 3. 3 equals negative 3. No? Good, so this 7 is not a solution. Right, so that's an example of a no solution. And now let's plug in 2. Right, just because one doesn't work doesn't mean the other will. You have to check both. So x equals 2, you want to check it's going to be 2 plus 2. Under radical equals 4 minus 2. And then 2 plus 2 is 4, so the square root of 4 is 2. Is that true? Yeah. Right, we get 2 equals 2. So x equals 2 is our only solution here. All right, so that maybe be the hardest part is clearing the radical. Because let's say, for instance, you had a square root of x plus 2 minus 1 equals negative 5 plus x. Right, something like that. What would you have to do first before squaring everything? Okay, is it here? So what are we going to want to do first? Okay, let's add the 1. Right, and we're not going to solve this because we just did it. All right, but that's what you want to do first, right? When it's written like this, you can't square it yet. So you have to clear whatever is next to the radical first so that you're able to square it, because once you square it, you get a quadratic equation. All right, let's try a rational. Yeah, let's try a rational equation now. Let's try 11, right? Let's start with 11, and then we'll try 12. So 11 is going to be, what, x equals 3 over x plus 1/2. Right, so rational equations, we first want to clear the denominators. Right, and we did it by multiplying by what? The entire equation. All right, we want to multiply by the least common denominator, right? So x and 2, right? There's an x here and a 2 here. They don't share anything in common, so you can multiply everything by 2x. And then 2x times x, nothing cancels there. We get 2x squared. 3 over x times 2x, the x's are going to cancel. And we're just left with 2 times 3. And then plus 1/2 times 2x, the 2's are going to cancel. So we're left with just 1 times x. And now this is a quadratic equation. We have 2x squared equals 6 plus x. And now set it equal to 0 and solve. So let's subtract 6, subtract x. So we get 2x squared minus x minus 6 equals 0. And then let's see if we can factor it. So we want factors of 2 times negative 6, so negative 12. Factors of negative 12 that add to negative 1. Can we think of anything? Okay, good. Negative 4 and 3. Now, since there's something in front of our x squared, we want to split up the middle term and factor it by grouping. So we get 2x squared minus 4x plus 3x minus 6 equals 0. And then group the first two and then group the second two. In the first group, you can take out a 2x, and you're left with an x minus 2. In the second group, you can take out a 3, and you're left with an x minus 2. So we get 2x plus 3 times x minus 2 equals 0. And then set each factor equal to 0. So we get 2x plus 3 equals 0. X minus 2 equals 0. And then subtract 3 from both sides. We get 2x equals negative 3. Divide both sides by 2, we get x equals negative 3 halves. Let's add the 2 on both sides, and then we get x equals 2. Right, we get our two answers. You do want to check these and make sure that your denominator isn't what? 0. Right? With rational equations, you don't want a denominator of 0. When you plug in 2 and negative 3 halves into the denominator here, are you going to get 0? No. Right? So these solutions work. Right? This check is a lot less rigorous than the radicals. Right? But it's still necessary to check just to make sure that you don't have any extraneous solutions. Now, for instance, something like number 13. Right, I won't finish this with you guys, but before we start multiplying by the denominator, what do we want to make sure we do to all of the denominators? Make sure that they are what? What can we do to this x squared minus 4? You can factor it, right? So make sure that you factor all of it just to make sure that you're not multiplying by too many things. Right, because now notice you have an x plus 2 in 2 spaces. Right, so then for this one, you would just multiply the entire equation by x minus 2 and x plus 2. Okay, what else can we do? Let's try 15 together, and then we can finish there. Okay, so 15 is one with a fraction in the exponent. Right, so you maybe see something like this. So with the fractional exponents, you want to treat them the same way that you would the radical equations. In the radical equations, we wanted the radicals by itself. But here we want the expression that has the fraction and the exponent. We want that by itself. Right, so what are we going to do first to get it by itself? Okay, let's add 25. We get x minus 1 to the 2/3 equals 25. All right, and now let's clear that fraction. What are we going to do to clear that fraction? Not cube root it. Raise, okay, you would raise both sides to the power of 3. If there's a 3 in the bottom of an exponent, and you raise it to the power of 3, power to a power you can multiply, so then the 3 and the 3 are going to cancel. So then we get x minus 1 to the second power equals 25 to the third power, right? But don't evaluate it because I'll show you what we can do now. Okay, so from here, notice that you have something squared and you have a constant, right? It's a constant that's cubed, but it's still a constant. So what can we do to both sides to clear that square? So opposite of squaring something. Square root. Let's square root both sides. So then we get x minus 1 equals plus or minus the square root of 25 cubed. If you remember from our radicals section, these are interchangeable, right? So 25 cubed under the radical is the same as if you were to first square root 25 and then cube it, right? They mean the same thing, they're interchangeable. Right, so that's what we're going to do first, but one of them is easier to do than the other. So you don't want to cube 25 and then take the square root of that big number. It's easier to first take the square root of 25 and then cube it. So we get x minus 1 is plus or minus 5 to the third power. And that's a lot easier to do than if you were to cube 25. So we get x minus 1 is plus or minus 125. And then you can add 1 on both sides. We get x equals 1 plus or minus 125. And because these are whole numbers, you want to split it up and get 2 answers. So 1 plus 125 and 1 minus 125. So we get 126 and negative 124. Now, because this is an odd root, so you have an odd number in the denominator, you don't have to check it. If you get something that's negative, that's allowed to happen. You're allowed to take the cube root and get a negative.